Hello again, everybody. It's me. Everything worked out right. Today is Tuesday, and you're hearing this on a Tuesday. Hopefully it has. I hope the technology is working fine. If not, you may not be hearing this, but here we are. All right, so I said yesterday, and we're going to work on number 45 here. This is question number 45 out of the book. It's a question about someone who rides a bike. All right, so we need some props here, because you always need to draw pictures anytime you got word problems. So you got a bicycle. Well, we'll just go with one wheel. We know a bicycle has two, but we'll just go with one for now. It has some information. The radius of the wheel is 13 inches. So it's a 13-inch radius wheel. When she is traveling at a speed of 45 feet per second, or 44, sorry, 44 per second means ratio. How many revolutions per minute? So you want your answer to be in revolutions per minute. All right, so you got a choice. We got to get rid of some things. We got to get feet to become revolutions. We got to make seconds become minutes. So let's start with seconds to minutes. We're going to start seconds to minutes. All right, so seconds. We want to get rid of seconds. We want to pick up minutes. We want 1 minute, which is 60 seconds. That will mean the seconds cancel out, and I got minutes, so that makes that work. All right, so now I've got to make revolutions. So let's see, I need revolutions. 1 revolution is how many feet? All right, so we got to do some thinking here. This is 13 inches, and that's a radius, but it's not the radius that's going around. It's the distance around the outside. It's that circumference again. It's just like the CD problem we did. It's that pink distance around that's going around. That's what we have to figure out. So let's figure that out. Let's go with blue. So 1 revolution equals, remember what we did the other day? We did a revolution is a circumference, 2 pi times radius, which is 13. So 1 revolution is 26 pi's. And now be careful, because this is inches. We don't want inches, we want feet. Because this is feet, so we got to get rid of the word feet. So we got to convert this to feet. So how many inches are in 1 foot? We'll do another conversion. Inches, you got 12. You got 1 foot. All right, so let's do some magic here. We'll cancel that out. That leaves me with 6. Cancel that out. It's 13. So this turns out to be 13 pi over 6 feet. So here I'm going to put 13 pi over 6. That's going to get us there, because it's going to be minutes are there, feet are going to cancel. I'm ending up with revolutions and minutes. So now you got to do is type it in the calculator. So let's pull up the calculator. Type in what I've got. I got 44 times 60 times, this is a complex fraction, so we're going to go complex fraction with a numerator of 1, because it's got 1. In the denominator, we got another complex fraction. We have 13 pi over 6. And I'm going to close that parenthesis out right there. Now my calculator does this. If you're doing it in yours, you're going to need parentheses around a whole lot of other stuff. So I'll show you another way to type that in. So this is 387. 387.85 revolutions per minute. Whoa, sorry about that. Go ahead and let you catch up there if you haven't gotten that, but that's how you get there. Ask yourself, what am I trying to get to? Revolutions per minute. That's what your final answer wants to be. What am I starting with? Feet per second. I got to get rid of seconds and pick up minutes. I got to get rid of feet and pick up revolutions. You got to keep in mind the problem was given to me in inches, so I got to convert that to feet. All right, so in your calculator doesn't do fancy fractions. So let me show you. Let me delete all this. Similar, 44 times 60 times one set of parentheses for the first fraction, 1 divided by parentheses 13 times pi, close that, divided by 6. So it's going to do the parenthesis stuff first, divide by 6. I should probably enclose that. You can never have too many parentheses. You can always have not enough. Because I want it to calculate that denominator first, that stuff inside the red. So it's going to do the green, then the red, and then the blue parentheses. You end up with the same answer. But you need to make sure you put those extra parentheses in there, otherwise you'll get the wrong answer. All right, so there we have it. New stuff for today. We're going to start some new stuff today. Today we are starting trig. And I always have stories to tell. So here's my story to tell. And this is actually what happened a long time ago. Ancient people, I think it was the Babylonians, were looking at shadows. So somebody standing out notices their shadow. The sun is shining over here. That's the sun. Sun is shining. Notice their shadow being cast on the ground at that time of day. Somebody else, that same person, notices that you've got a small tree or a small stick sticking out of the ground there. It's also casting a shadow. Now they're very smart people, Babylonians and the Egyptians. They realize, hey, wait a minute. These are similar triangles. And they know from their studies that similar triangles have the same angles. Right angle, right angle. Angle theta. This is called a theta, by the way. Looks like a circle with a line through it. And we'll call this one angle beta, or angle B. They've got similar triangles. The other thing they have is they have ratios that are the same. Ratios are the same. So the person, call this side A, B, and C. On the little side they have A, B, and C. So they realize that the ratios are the same. The ratios of corresponding sides. So A over A is the same thing as B over B, which is the same thing as small c over big C. And the ratios can be changed. You could go big A over little a, big B over big B, little b, big C over little c. Those ratios are always the same. So another smart mathematician decided, hey, you know what? Those angles are the same and the ratios are the same. I can make a generalization. Trig is the study of triangle relationships. Notice that if this angle is 30 degrees, these ratios are always the same number. So whatever these numbers are, this ratio is always the same. So they decided, you know what, I've got a couple of different relationships here, a couple of different ratios I can come up with. So let's give them a name. So they came up with names for the relationships. They named the ratios. So we've got all these different ratios, and they're saying, okay, we're going to go based on the 30-degree angle, based on where I'm looking at. So they came up with a very generic looking right triangle. This only works for right triangles is the other thing they noticed. And you have to have a point of view. Where am I looking from? Where is this angle theta that I look from? And they said, you know what? We need to be able to identify things. So for the sake of consistency, across from the big right angle is always the hypotenuse. It's always across from the right angle. So then they came up with two other names. The angle that's across from the angle is the side that's called the opposite, which left me with one. The one that's next to the angle, the one that's made up of the hypotenuse and the side next to it, the side next to the angle is called the adjacent because it's next to it. And they realized, hey, wait a minute, there's only so many ratios I can make. I can make a ratio when I'm looking from my eye here. If you think about this as your eyeball, there's your eyeball. If you're looking from your eyeball, one ratio I could make is the opposite side over the hypotenuse. So they said, well, we have one that's called OH, opposite side over hypotenuse. If I do that again, I can go the adjacent side over the hypotenuse. That's A over H. And the only other one I've got left is if I go opposite over adjacent. And they thought, you know what? I can actually make these go backwards. If I went A over O, H over A, or H over O. We won't worry about those for now. These we'll worry about on a different day. In fact, I think we'll worry about them on Thursday. So we'll worry about these Thursday. So we'll put those out of our minds for now. Imagine that those aren't there. But I thought, you know what? I'm looking from the same place. I'm looking from this place called theta, this angle. And theta is never the right angle. Never, ever the right angle. So they decided to give these things names. Let's give them names. So I'm going to give it the name of a sine. That's my first ratio. I'm going to call it the sine when I'm looking from this angle theta, and that ratio is going to be called the opposite over the hypotenuse. The second one is going to be called the cosine because it's the second one. First one is sine, second one is a cosine. And that one's going to be made up of my adjacent side with my hypotenuse. And again, it's just the ratios of these measures. And the third one we're going to call the tangent. And that's going to be the opposite side over the adjacent side. All trig problems are identical. Identical. They are exactly the same. You're going to either know an angle or find an angle. You're going to know one of the two sides or both of the sides if you're looking for the angle. And I'll show you three examples of the three different kinds of problems you're going to see. All right, so let's fill in our ratios. We're going to start with the right triangle. And again, it depends on where your eyeball is looking from. Let's say we're going to put our eyeball theta up at the top here. Let's say we've got a 3, 4, 5 right triangle. So we're going to make a 4, a 3, and a 5. That's a right triangle we all know. That's a 3, 4, 5. So again, you're looking from, where am I looking at? I'm looking from theta. So first thing I got to identify is where's my hypotenuse? There it is. Hypotenuse. Why is that the hypotenuse? It's across from the right angle. Second thing I got to identify is where's the opposite side? Well, here's my eye. What does my eye see? It sees what's across from me. So that's the opposite. You never see what's next to you. So what's next to you is what's left. That's the adjacent side. All right, so then you're going to be asked questions like, what is the sine, cosine, and tangent of theta? The sine, abbreviated SIN, of theta. Now you got to remember your ratios. Sine is OH. Cosine, theta, it's COS. It's AH. Tangent, theta, is OA. Sine OH, cosine AH, tangent OA. You may have learned SOHCAHTOA. SOHCAHTOA. Time for a crazy visual. Here's how I remember it. Trigonometry makes me feel so good. I have to soak a toe. So this is what that means. This is what I have in mind when I do trig. Wait for it. There's a joke here. That's my toe. I'm going to put my tub here. It's a steaming tub. Warm water, warm water, warm water. My big sore toe is in there. Here's my sore toe. It's got water in there. Trigonometry makes me feel so good. I soak a toe and I say, SOHCAHTOA. SOHCAHTOA. That's kind of corny. There you have it. Now all you got to do is fill in the blanks. Always fill in your sine, cosine, theta. What are the ratios? And then fill in the blanks. Answer the question. What are the ratios? Sine, opposite, 3, hypotenuse, 5. Cosine, 4, 5. Tangent, 3, 4. You can't mess this up. You make the right ratios, you fill in the blanks. Simple. Every problem works the same way, though. Exactly the same way. Fill out the ratios. What do you know? Fill out the ratios. So you're going to be, excuse me. All right, so you're going to be given problems where you're either going to find an angle or find the missing part of the ratio. Every problem is the same. Trigonometry is so boring because every problem is the same. Draw yourself a generic triangle. Let's say I've got an angle here of 35 degrees. And I know the hypotenuse is 10. I have to find the side opposite. Okay? I have to find the side opposite. You are sitting watching TV. The top of the TV is 10 feet away from your eyeball. Here's your eyeball. This is you watching TV. It's your favorite show. From your eyeball to the top of this big screen TV is 10 feet. How big is the TV? Oh, I don't know. Call it X. Call it A. Call it anything. All right, so now let's look at it. What do we know? We know the hypotenuse. And we know the opposite, because it's opposite your eye. So which ratio is that? Opposite hypotenuse. Is it sine of the angle is OH? Is it cosine of the angle, which is AH? Or is it tangent of the angle, which is OA? Well, it's not that one, because that's AH. It's not tangent, because it's OA. So it's sine. All right, so I'm using sine of theta. Equals, I always start out with the same thing, OH. I identify it, I use it. That's what I'm using. Fill in the blank time. Sine of the angle. Well, how big is the angle? The angle is 35 degrees. Equals Opposite, I don't know. Hypotenuse, 10. All right, think time now. How do you get x by itself? Well, I got to get rid of the 10. Multiply both sides by 10. That's it. Whatever this answer turns out to be is what x is. So let's use some calculator here. The only thing you got to check for your calculator is make sure you're in degree mode. If you're in your TI, make sure your mode is degrees. Let me pull up my TI, so let me pause for a second. All right, I've pulled up my TI calculator here. So if you've got a TI calculator, if not, there's some in the closet, so go get some. Just make sure you bring them back. So here's my mode key. Mode key, normal. I don't want to be in radians. I want to be in degrees. Okay, so I press mode, go down. Where it said radians, I want degrees to be blinking on and off. Second, quit, get back out of there. And then we're going to type this in. 10 sine of 35, it's already in degrees, gives you my answer. From top to bottom, the screen is x is 5.7. We can call that feet. 5.7 feet tall. Same type of issue. If you wanted to find how far away from the TV you are, you would use a different ratio. You're probably going to use cosines. Well, so let's take a look at that problem. So let me just go ahead and copy this stuff. I want to copy all of this stuff. I want to take my picture with me. So I will copy it and I'll put it on the new page. There you have it, same thing. So now I want to find out how far from the screen is your eyeball. So this time I'm going to call that y. Since I already have x up there, I'm going to call it y. All right, so same thing. Let's identify. We don't know this. That's still the opposite side. Now I have the adjacent side I have to work with. So then you ask yourself, is it a sine of an angle? Is it cosine of an angle? Or is it tangent of an angle? All right, so let's see. We know a hypotenuse and adjacent, so I got to use that one. I could have used OA since I do know that's 5.7, but let's just assume we only know the hypotenuse. You want to know 2 out of 3 things. This cosine is going to give me 2 out of 3 things. So you're starting out with cosine of theta is A over H. All right, so let's fill in the blanks. What is theta? How big is the angle? 35 degrees. What is the adjacent? I don't know. A, or call it y. It's called y there. How big is the hypotenuse? 10. Well, then plug this in. Multiply by 10. Get that y all by itself. So now y equals, type it in the calculator, 10, whoops, 10 cosine, because it says cosine right there, 35. Close that. 8.2. So you're 8.2 feet away from the screen. If you're trying to find the hypotenuse, you got to do a little more algebra, but it's not a big deal. Say I don't know how big that angle is. How big is that angle? That's the only other type of question you could have. You're either going to have to find the sides or find the angle. Here I am, some angle theta. I don't know what it is today. Let's say I've got information that says this is 12 and this is 50. All right, so we're talking about a tree here. How tall is the tree? If it casts a 12-foot shadow, and there's a guide wire or a guy wire that goes from top to bottom, it's 50 feet. What's the angle the wire is attached? So we're going to find the angle of the wire and the height of the tree. How tall is the tree? Two questions. All right, so let's go at it here. Let's figure it out. Figure out what kind of ratio you're looking at. I know the hypotenuse, that's h, because it's across from the right angle. Opposite, where's my eye? What am I looking at? That's my opposite. What don't I see is the stuff that's next to me. All right, so let's see. Is it a sine of theta, which is OH? Is it a cosine of theta, which is AH? Is it a tangent of theta, OA? All right, let's see. I've got information about H and A. H and A, that's a cosine. So I'm going to start with a cosine. Cosine of theta equals, start with the ratio, A over H. Don't be lazy. Don't jump into it. Fill it out. Do I know the cosine of the angle? No, I don't. So I have the cosine of the angle is what I'm trying to find. I do know the adjacent side is 12. I do know hypotenuse is 50. We'll come back and find the opposite in a second. Let's find the angle first. All right. Do I want the cosine of the angle? No. What's keeping that cosine from being alone? Or I'm sorry, what's keeping the theta from being alone? Theta wants to be by itself. We want to find out theta. If it wasn't for this cosine, I could get it by itself. Calculators have undo keys. You can undo cosine. How? Right above cosine. See? Cosine with a -1, that's called an arc cosine. That's finding angles. It's your undo key. So theta is the undo of cosine when it's 12 over 50. And it's because I got to get this theta by itself. You got to pry it apart. Algebra is about working things backwards. How do I undo the word cosine? You do a second cosine. Second cosine is undo cosine. There it is. When it's 12 divided by 50. Again, I'm in degree mode, so we're talking about an angle of 76 degrees. 76.11. And if I'm going too fast, your sub can always rewind. So, or you can watch this on YouTube. It'll be on. It'll be up. All right. So that's that first part. All right. So the angle 76. So now we have to find how tall is the tree. How tall is the tree? And all trig problems are the same. Identify your ratio. I need a ratio that has the opposite and either the adjacent or the hypotenuse. Doesn't make a difference. Let's be different. Let's go with opposite and adjacent. Well, opposite and adjacent. And the second one is going to be a tangent. Tangent of theta, which we already know right now. That's 76.11. Equals the opposite, which I don't know. Adjacent is 12. We did a problem like that. You multiply by 12. 12 tangents of 76.11. 48 feet. 48 and change, 48.5. All right, occasionally you will have a problem where you have to find the x on the bottom. Let's just throw one in here. Let's say you have the sine of 15 degrees equals 10 over x. Undo thing, you got to work it backwards. So you're going to multiply both sides by x and divide by sine, or let's do the flip-flop. X is 10 over the sine of 15. Because I have to multiply by x and then divide by the sine of 15. Which is just the flip-flop. When the x is on the bottom, you flip-flop. It's algebra tricks. So you just take 10 divided by the sine of 15. Close that. Get your answer. So that's if you have thing on the bottom. It's algebra stuff. It's really not, don't make it a difficult thing. But again, all trig problems are exactly the same. Let me show you an example. So let me go find the example and I'll bring it right back. Ooh, through the video magic. There it is. Kirsten places her surveyor's telescope on top of a tripod 5 feet above the ground. Alright, so we got some kind of a triangle. Let's draw a triangle. Oh, you know what? I've got a triangle tool, so let me just do that. Here it is, nice little right triangle. Magic. There you have it. Alright, so it says 5 feet above the ground. So it's 5 feet above the ground. Here's her eyeball right here. She measures an angle of elevation. Elevation means you look up. You got two kinds of angles. You could either be looking up, elevation, or you could be looking down. Now when you look down like this. So it's an upside down right triangle. So this is depression. You don't look down straight down. Never look straight down. You never look straight down. So your eyeball is never going to be going that way because it means you're falling. If elevation and depression are the same, so you could actually draw the same picture. These are the same. So if I draw this same generic triangle every time, elevation and depression are both this angle. Those are both the same. Elevation and depression. They're the same angle. That's that one below. It's never that one above. Alright, so that's your angle of elevation. She measures 8 degrees. So this is 8 degrees. Top of a tree that's 120 feet away. So it's 120 feet away. She measures an 8-degree angle of elevation above the horizon, above the horizontal. Oh, she's trying to measure a tree, and this thing is 5 feet above the ground. So I got to move my 5 feet. This 5 feet is actually right there because her tripod has her telescope. So we have a telescope. This little tripod looks like this. That has her scope on it, and actually it's on the wrong side. So let me move this on the other side. It's like that. I gotta move this 5 feet on this side. Alright, so it's already 5 feet up off the ground. She's standing here trying to measure her tree. She's eyeballing it. That's her. She's looking through that telescope right there, and she's 5 feet up off the ground. 120 feet away. She doesn't know how tall it is. Again, same problem. Always the same problem. Let's see, I got information about angle, adjacent, and opposite. Because this is hypotenuse. Opposite, adjacent. So let's see, that's OA, that's tangent. Tangent of an angle is opposite over adjacent. TOA. How big is the angle? Oh, it's 8 degrees. What's the side opposite? I have no idea. What's the adjacent? 120. Throw it in the calculator. 120 tangents of 8. 16.86. Every problem is the same. This problem, by the way, is number 65 on the thing. Let me see if that's it. Alright, so that's sine, cosine, and tangent. There are 3 other ratios that I talked about that were supposed to be Thursdays. So let's actually take a look at them today because it's not harder at all. It's actually easier. So we had the original 3 ratios, sine, cosine, and tangent. And there's other 3 that are the opposite. So I'm going to go down to the end. Let's talk about the other 3 because they gave those other names. And those names, slightly different. And those are not on your calculator. So your calculator has sine, cosine, and tangent. Those are your calculator ones. Theta, theta, theta. OH, SOC, AH, TOA, OA. SOCATOA. Okay, now you've got another set. These are the opposites. Tangent you left off with, so we're going to go cotangent. Let me change colors on you here to really make these jump out at you, because these you need to know these as well. So we have cotangent. And now you start flipping them. These are opposite. AO. Secant, abbreviated SEC, is the opposite of cosine. So cosine is AH, the opposite is HA. And finally, sine, cosecant. That has a 3 CSC is actually the abbreviation for it. Let me scratch that out because cosecant is abbreviated CSC of theta. Just like secant, cosecant. And that's the opposite of sine, which is H over O. Same thing. You have a triangle. 3, 4, 5. Angle theta down below there. Fill in the blanks. Hypotenuse, opposite, adjacent. Fill them in. So we fill them in. So we go, okay, OH 4, 5. AH 3, 5. OA 4, 3. Doesn't matter if it's an improper fraction. Leave it alone. Then you go 3, 4. You start flipping O over. 5 over 3. 5 over 4. Again, does not matter if it's an improper fraction. Your calculator does not have these buttons. If you're asked to calculate those, calculate the sine, the cosine, or the tangent, and take 1 divided by that answer. You shouldn't be. If you just have the ratio, that's all you need. You really don't need anything else. Okay, so you got some questions on your assignments that look like this. So let's go down to, you're doing numbers 3 to 39, and you're doing every third one. So we got to do that. So let's see. 3 to 39. Let's look at some like 9 through 17. Let's go with 17. It says the cosecant of theta is 23 over 9. Cosecant of theta is 23 over 9. All right, so again, every problem is the same. What am I missing from my problem? Well, I need a triangle, so I need a right triangle. There it is. Need an angle theta. Always draw the same picture. Cosecant. If you look at the one before, let's see where cosecant lies. Cosecant is the opposite of sine, so it's HO. So this is HO. Hypotenuse is 23. Opposite is 9. Hey, Pythagorean theorem. 9 squared plus x squared equals 23 squared. Solve that thing for x. X is 23 squared minus 9 squared, all underneath the square root. (23 squared minus 9 squared). 8 root 7. Fill in the rest of the ratios. What's sine, what's cosine, what's tangent. You've got the stuff, so just fill it out. That's what it's talking about. And it's going to change the ratio. The ratio is going to change. Look at the relationship, fill in the picture, answer the last one using Pythagorean theorem. Evaluate without using your calculator. Okay, these are in radian mode, so like number 19. The sine of pi over 3. All right, number 19. Sine of pi over 3. Now this is in radian mode. It says no calculator. So guess what? We do know how to convert that to degrees. Pi over 3 equals something in degrees. So I got to convert that to degrees. Oh, you know what? I got to get rid of some stuff. I got to get rid of the equals here. Which is 180 over pi. Pi's go away. you end up with 60 degrees. So what's the sine of 60 degrees? Well, let's put it in the calculator. Sine of 60. Square root of 3 over 2. All right. Or you could have put the decimal down. The decimal for that one. Let's see what the TI says it is. Sine of 60 degrees. 0.86. Could have done that too. 0.866. All right, so there you have it. This is a special right triangle. We'll talk about those later. 49, 51, 57. So let's see, 49, 51, 57. 49, 57. All right, 57, you got to find B and A. So you're going to be given all the information. Solve the triangle, given the known parts. So you know B, beta, 55. You know A. You got to fill in the other ones. Not difficult. That should be a simple process. All right. Anything that's in radians, anything that has a pi in it that has radians, convert those first. If it's got minutes or seconds, convert those first into a decimal, and then work it from there. All right. I'll have answers for you tomorrow on some of these. Not all of them. We'll have answers for some of them. All right. The rest of the time you can work on the assignment, which is day number 3. Day number 3, page 366. 4.2. All right. See you tomorrow.